It's going to be a very interactive session, so I need you all to be very active and to as we proceed in the class. I believe we all understand why we are discussing sampling technique. We have been introduced to the fundamentals about research. Why do we do research? Research, I just want to do a few minutes. What do you call it? What is research? Is somebody here to talk to me about that? What is research?
I would
Okay.
say research is a systematic inquiry into a body of knowledge in order to identify gaps and fill in such gaps.
Thank you. That's a very smart response. I really appreciate that. Continue. Is there someone else? Just let's get
Just
one
let's
more.
get one more.
So,
All right, sir. Research is systematic investigation of a phenomenon related to improving nursing care, that is related to nursing, to answer questions, to find solutions to specific nursing problem, and provide quality care that is safe, timely, warning, cautioned, and enhance skills.
that is a
That is
very
a very
beautiful
beautiful
response. Thank you
response.
so
Thank you
much.
so
I
much.
mean, those two of you that responded, I couldn't see those who are in the chat box. You guys have really done justice to what research simply means. I mean, it's simply put the way you guys have defined it. It's a program, a systematic program of inquiry to inquire, to have information about a particular phenomenon of interest. That is what research is all about. And like I said, and like you also actually said, it is systematic, meaning that there are systems, there are methods to follow. And there is also a concept of reproducibility in research, such that when you follow the systems, when you follow the method, if carried out somewhere else, you can get the same result. The same thing can be repeated. And that is hence why we talk about the systematic approach and the methodical approach of in programs of inquiry. So you are absolutely correct. When you want to do research, you have when you talk about phenomenon of interest, you are talking about population. Okay, we want to inquire about this phenomenon of interest, this topic of interest within a particular population. I'm sure all of us are familiar with what we call the Sustainable Development Goals. We have 17 of them, and all that we do, whether you are a nurse, whether you are a medical doctor, you are a pharmacist, you're a dentist, you're a carpenter, you are a farmer, all we do are relating to the sustainable development goals. All that we do in research, all works of life that we do is for us to actually achieve what we call the sustainable development goals. Our sociological, what do you call it, life, how we live, what happened, what are the problems we faced, how do we also prevent problems, from happening, and of course, particularly to our profession, how do we improve patient care? How do we move from a practice that is not really advancing care to a practice that advances care? Why do we do research? I'm sure you know that has been discussed already, but today we are talking about sampling technique, and the aim of this is to equip nurses, nursing students, and my audience with knowledge and skills to select and apply appropriate sampling method, including correct, correctly determining sample size for finite and infinite populations to enhance the validity and generalizability of research findings. So this is a general aim for today's for today's class. Our learning objectives. By the end of this session, we should be able to define key concepts around sampling technique, which are population, target population, accessible population, sampling frame, and sample. We also will be able to explain the importance and purpose of sampling in research. We'll be able to differentiate between probability and non-probability sampling method. We'll be able to also identify the characteristics of an effective sampling frame. We would be able to distinguish between major sampling techniques such as simple random, stratified cluster, convenience, purposive quota, and snowball sampling. We'll also be able to describe the steps involved in sampling process. We'll be able to explain sampling error and the need for representativeness in research. We'll be able to differentiate correctly how to apply formulas, you know, in for determining sample size in finite and infinite populations. Also, we'll be able to make informed decisions on selecting appropriate sampling method and sample size based on our research purpose. Also, some of our learning outcome will be that will be able to accurately define and use key sampling terminologies in research discussions and practice. We'll be able to justify the significance of sampling and the role of sampling frame. We'll be able to appropriately classify sampling method as such as probability and non-probability sampling method. We'll be able to critically compare sampling strategies and also choose suitable methods for various research contexts. Also, some of the things we'll be learning in today's class is also we'll be able to outline and follow correct sequence of steps in sampling. We'll also be able to recognize and explain sampling errors and factors affecting representativeness. I hope we have enough time to be able to cover all of these though. Also, we'll be able to correctly select and use appropriate formulas for calculating sample size for finite and infinite populations. Also, we'll be able to demonstrate the ability to choose and justify a sampling method and sample size in a research proposal. So let's get to it. What is sampling technique? What is sampling technique all about? I have said, when we want to do a research, when we want to do in a program of inquiry, we are interested to understand or to study, to carry out a study or to inquire about a phenomenon of interest within a particular population. For example, when we talk about Nigeria, Nigeria is a population, right? So, what is population? Population is the entire set of an item or event, comprehensive set of data points, object or individual that possesses common characteristics and are of interest for a study. It also represents the total group about which conclusions are to be drawn. Populations can be finite. For example, all students in nursing schools. So when you talk about all students in a nursing school, for example, let's talk about University of Ibadan, for example. That's a nursing school. So all the students in the University of Nursing School are finite. But when we talk about infinite population, we're talking about all possible coin flipped. So when we talk about that, we can say nursing students. So when we talk about nursing students in Nigeria, in fact, Nigerian nursing students, for example. So we have Nigerian nursing students in the UK, we have Nigerian nursing students in Canada, we have Nigerian nursing students in the US, right? We have Nigerian nursing students in Cameroon. So that is an infinite example. I have given an example when we talk about finite population and populations that are non-finite or that are infinite. So for instance, all practicing registered nurses in private and public healthcare facilities in Nigeria, they are estimated to be about 280,000. So when we talk about, it is an example I wanted to give us here. When we talk about all practicing registered nurses in public and private sector in Nigeria, I want somebody to answer us. Is this a finite population or infinite population?
Infinite population.
Are you
In
sure?
Nigeria, finite population, sir.
Okay. So because we already have Nigeria, that is a finite population. Because we already say, but when you say registered nurses in public and private hospitals, you are not specific about Nigeria, you're not specific about Africa. It could be in the US, it could be in the UK, it could be in India, it could be in Australia. That is non-finite. We are not able to specifically say this is the total number. Thank you for that response. So population is usually denoted as N. Please let's note that population is usually denoted as, don't forget, population is the entire set. You remember your Venn diagram? Is the entire set of what? Of a data points. Objects, individuals, events could be all encompassing. In research, population refers to a complete set of individual objects, events, or observations that share specific characteristics and about which a researcher wants to draw conclusion. It is the entire group of interest not just those who are studied directly. Understanding population is very fundamental because all the statistical analysis and inferences are ultimately aimed at saying something meaningful about the population group. So before we want to, let's say we want to do a study, we are interested, and you know that, I don't know, I remember that Professor Adejumo, my super mentor, taught you last, I think it was last week, about research, about introduction to research. And you know that when you are coming up or you are designing your research topic, there are key elements that should reflect in your research, what do you call it, research topic, which is your studies setting, your study state setting, your study population, right? You can say knowledge, attitude, and practice of registered nurses in public and private, in selected public and private facilities in Oyo South Senatorial District over surgical wound care, for example. You know, you have already given us an example of your what? Of your sample, of a population, of your sample, where who are those you are interested in studying about. So let's move forward. Population can be classified into different types. We have the target population. And what are target population? Target population, which is a group population wants to generalize findings to, for example, all adults with diabetes in Nigeria. All adults with diabetes in Nigeria. Can somebody answer me? Is this a finite population or non-finite population?
Finite.
It's finite because we know adults start from
Finite.
people who are
Finite,
18
sir.
plus. Thank you. People who are 18 plus, right? But Nigeria is very, very big. But because we're able to capture them within a geographical location, so we can say, oh yes, this is finite. Thank you. But what is target population? It is, they are the particular group. We have already shown our interest. So they are the group that
Kini.
a researcher have.
The network now.
Sorry, can we mute if you are not talking? Thank you, thank you, thank you. So they are the group that a researcher already have interest in studying something interesting about, something unique about them. They are the targets, what do you call it, population of interest. You know that we have a large population. We have talked about population as the overall population. What is target population? So in the overall population, we're talking about who are those that we are now interested in this population. Oh, all adults, male or female, irrespective of socioeconomic factor, what do you call it, gender, comorbidity, whatever factor that we could, other factor that will come in place. But as long as you have these characteristics, which is diabetes, and you are above 18, we are interested. So those are target population. An accessible population in the portion of the target population, the researcher can realistically reach, such as diabetic patients attending selected hospitals. A study population is a group that actually meets the inclusion. Don't forget to talk about target population. We also have accessible population. Now we are talking about study population. A study population is a group that actually meets the inclusion criteria from which a sample of the study is drawn. So we should not mix population, target population, accessible population, and study population together. Study population is a group that meets an inclusion criteria for which. So when we talk about study population, like I'll give an example. For example, we talk about, let's say, all all male adults living with diabetics. All male adults living with diabetes in Nigeria. Has that given you an example? All male adults. In the target population, we talk about all adults, right? Now we are having a specific inclusion criteria. You have to be a male. So we can now design, okay, maybe we have a research topic that is saying that, oh, we are interested in male adults who are living with diabetes. We want to understand how they have that. Maybe they want to do a program of inquiry to understand if it was truly hereditary or it was nutritional factor. Still on how population can be classified. We have thought of it can classify such as, okay, still example on how populations can be classified, such as students in a particular school, or such as, population can be also finite, such as all students in a particular school, or infinite, such as all students. Okay, population can also be finite, such as all students in a particular school, or infinite, such as possible outcome of repeated coin toss, as said earlier. We have talked about this. I'm just giving an example here. In statistics, population parameters are numerical. Please note this. In statistics, population parameters are numerical values that describe the characteristics of a population. These parameters are usually unknown and are estimated using sample statistics. And that is why we are here to understand the concept of sampling technique. Some common population parameters and their formulas include the following. Like I said, population width is denoted by what? By n. N equals to total number of elements in the population. Population mean represents the average value of a variable for the entire population and is denoted by mu, which is a Greek letter. You can see it on my screen, mu. So what is the population? So we have a formula for population. Population mean formula. So there's something called population mean formula. What is population mean? Population mean is what? The average value of a variable for an entire, what do you call it, population. So we have mu, which equals to the sum of population value divided by the population size. And we can see that on my screen here. We can see mu equals summation, what do you call it, summation n equals to x. Our x is what? Mean of the total population over total population. So where x represents the individual value of the population. So the individual value of the population is where we have our x, and we have our n to be the population size. So we have something we also call population variance. Population variance measures how the spread out of the population value are around the mean and is denoted by sigma, or sigma square, sorry. So this is population variance and standard variation formula. Population variance measures how the spread of the population. Please, if you have any question, please put it in the chat box. Mr. Jerry, please kindly help note all the questions because I can't see what is going on in the chat box right now. So population variance measures how the spread of the population values and are around the mean and is denoted by sigma square, as we can see. You can see the summation n, which equals to, we know what our x denotes from the previous slide, minus our mu raised to power 2 divided by the total population. That is how we calculate our population variance. Then population standard deviation is square root of population variance and is denoted by sigma. This is the sign for sigma. So our population variance is square root of what? Population variance. This exact formula that we have our population variance, the square root of it will give us our population standard deviation formula. So let's talk about population proportion formula. In probability and sampling theory, population proportion is another important parameter. Population proportion, especially for categorical data. And we're going to be talking about categorical data as we move on in this discussion. It represents the fraction of a population with a specific characteristics denoted by P. Recall, I talked about all adult male living with diabetes. So we can call that what? Here, the fraction of the population with a specific characteristics. Two characteristics we are talking about. They are adults, meaning they are more than 18, and they are male, and they also have what? They also have diabetes. So in this place, it's referring a fraction of the population with a specific characteristic and divided by P. So population proportion formula here is what? P equals to X over N. Recall our X is what? X is the number of individuals in the population with characteristics of interest. So our X here is every individual who probably, like I gave you in the example, that all male adults who are living with, what do you call it, diabetes in Nigeria. So our X total number is the number of individuals in the population with the characteristics of interest. Are we following? So let's talk about population proportion. Let's talk about population proportion. It is very important to know that in most real studies, researchers cannot measure the entire population. To be realistic, let us now be pragmatic now. I mean, in Nigeria, the last time we did census was probably 2004, 2006, right? So we cannot even say you are running. We want to do a study that covers the whole of Nigeria because you are not even sure what exactly we've been running on statistical estimates of this is what we should probably be having because of what we had the last time. So instead, they select a sample and compute sample statistics such as sample mean, sample proportion, sample variance, and sample deviation, which are used to estimate the corresponding population parameters. Don't forget, we have talked about why is sample proportion formula important. Why are we talking about sample proportion? Why are we talking about sample variance? Why are we talking about standard deviation? Because it is practically impossible in the real world study for researchers to measure an entire population. We cannot say we want to do a research now, and we are let's say for example, we want to carry out research in the University of Ibadan, and you are saying all the students in the University of Ibadan should fill a questionnaire, for example. You mean all male and female students, all undergraduate, postgraduate students, and also the what do you call the maybe pre-degree or remedial program students. All it might be practically impossible for us to want to get all of them to respond to what do you call it, maybe our research instrument or something. So hence, while we have our sample proportion, sample variance, for us to select out of this, what do you call it, population that we have to be able to make an inference, an objective inference for our program of inquiry. So we talked about target population the other time. So what is target population? Target population is defined based on specific characteristics, which have been said earlier, relevant to research question. These characteristics may include demographic factors such as age, sex, occupation, clinical factors such as disease status or health condition, geographic location, or time-related factor. Clearly defining these characteristics helps ensure that study focuses on the correct group and that conclusions are meaningful. It acts as the focus for data collection and analysis, distinguishing it from the actual sample drawn. It is important to distinguish the target population from related concepts. The target population is broader and more conceptual than the accessible population, which is the portion of the target population the researcher can realistically reach. So don't forget that when we talk about target population, most times what I have seen is people actually, or students or researchers, some often mix target population and study population together. So I want to ask, from what we've been able to do in this class so far, can somebody tell me the difference between target population? You can unmute your mic and tell me what you understand as the difference between target population and study population.
Good evening, sir.
Yeah, good evening, Chief.
Yes, sir. So from this class, I was thinking that
Your
target
name
population.
and where you are from, your institution.
My name is Akintunde Akinsanyide Uju from Federal University of Ekiti, Department of
Okay,
Nursing, 500 level. All right. So
okay.
from this, I would say that target population is a broader concept. Like it talks about like the whole population that you want to pick out the sample from. So while study population is that particular sample that you bring out. That is what we call that's the difference between the target and the study population.
Please a round of applause for him. Please a round of applause. A round of applause. So example of target population was the example I initially gave, which has which features a demographic factor, right? A geographical factor and a clinical factor. We talked about all male adults, right? Living with diabetes. Those are target population. Study population are those that we are now particularly we have sampled out. So study population are taken out of target population. Thank you for that very brilliant response. The sample is moving forward. Okay, let's talk about the sample is a smaller subset selected from the assessable population and is the group from which data are actually collected. While the sample provides the data, the ultimate goal is to make inferences about the target population. For example, if our study aims to evaluate the effectiveness of a new malaria prevention strategy among pregnant women in Nigeria, the target population would be all pregnant women in Nigeria, as we have rightly said. However, the accessible population might be the pregnant women attending antenatal clinic in some selected hospitals during the study period, and the sample would be the women who are actually recruited into the study. That will be our study sample. Now, target population plays a critical role in external validity of study, which refers to the extent to which study findings can be generalized. If the target population is poorly defined or does not align with research objective, the results may not be applicable or may be misleading. So researchers must therefore state target population clearly in their methodology. In defining a target population, researchers often specify inclusion and exclusion criteria. And if you see from what are the definitions have been, what distinguishes target population from study population is what? Inclusion and exclusion criteria. Inclusion criteria describes the characteristics participants must have to participate in the population, while exclusion criteria identifies characteristics that disqualify certain individuals. Where formula are commonly used in relation to target population include population size. We know our population size, which is our N, total number of elements in target population, if known. Estimating characteristics of target population using a sample. For instance, the population mean is estimated by sample mean. And our sample mean is X bar summation, X bar summation, X over our N. Similarly, the population proportion P is estimated by the sample proportion. So we can say our sample proportion formula as X over N, where X is the number of sampled units. What are sample units? Those that we have picked within our sample, within our target population with the characteristics of interest. Our X is number of sample is what? Sample are those who have characteristics of interest for us to carry out our study. And N is the what? N is the sample size. So let's talk about sample size determination formula. So sample size determination formula are also indirectly linked to target population because they help decide how many units to study in order to make valid inferences about the target population. For example, for large population, a common sample size formula for estimating a proportion is what we can see on our screen here. Our N. Now, can we differentiate between when we have a small n and a capital N? Is anybody raising their hand? Target population.
The capital N is population.
What did you say?
Okay, I think the bigger N has to do with the total population, then the
Right.
smaller N has to do with the sample size.
Well, the smaller n is target population. We can
Yes,
call it
target
more of our
population.
target population. Thank you. Thank you for that beautiful response. Thank you. So, where our Z is what? Our Z is the standard normal value for desired confidence level, right? Our P is what? Estimated population proportion, right? And we we have our Q equals 1 minus P, and D is what? Margin error. I have not talked about margin error. Moving forward, I'll talk about all this formula one after the other. Some common review questions. Okay, so let's try to quickly address this before we move to the core mathematical side of the sample size calculation. How does identifying a target population impact the overall validity of a study? Identifying a target population is crucial for enhancing the validity of studies finding because it ensures that the results are applicable to the specific group being studied. We have talked about that. Sorry. A well-defined target population allows researchers to use appropriate sampling method to generalize their conclusions accurately. Without a clear understanding of who the study is focused on, researchers risk researchers risk producing findings that may not be relevant or applicable to the intended audience. Also, let's discuss the importance of inclusion and exclusion criteria in defining target population for research. Inclusion and exclusion criteria are vital in defining the target population because they establish clear guidelines for who can and cannot participate in a study. Inclusion criteria ensures participants possess specific characteristics necessary for addressing the research questions. All of these, I'm going to be making references back to them. While exclusion criteria help eliminate individuals who might introduce bias or confounding variables. Together, these criteria help research to refine their target population and improve the quality and relevance of practice. Evaluate how the definition, also some common review questions are also to evaluate how the definition of target population can influence research designs, decisions, and also outcomes in epidemiological studies. The definition of target population significantly influences research design decisions, and outcomes in epidemiological studies by shaping everything from sampling strategies to data collection method. When researchers clearly define their target population, they select appropriate tools and techniques tailored to that group's characteristics, which is to improve our data accuracy. This targeted approach also allows researchers to address specific public health concerns relevant to that population. For example, now we are talking about people who are experiencing climate change. Okay, all of us are experiencing climate change. Right? People who are experiencing conflicts. That means our target population in that aspect will be people who are living in northeastern Nigeria, right? People who are living in places like Sokoto, Zamfara, Borno states, right? Because they have something in
Yes, sir.
that the other population, you know, doesn't have, ultimately leading to more intervention and policy recommendations. Example, okay, we have some examples here as well. All registered nurses working in an inpatient medical surgical ward in federal tertiary institution across Nigeria's 6 geopolitical zones. All registered voters in California or patients with type 2 diabetes age 42. You know, the other time we were talking about people living with diabetes, we also did not talk whether we are talking about diabetes insipidus or diabetes mellitus, right? And that is where sampling comes in. That is why it is very important we understand the concept of population, target population, sampling, sampling frame, and all of that. Here we can see an example. All nurses working in federal tertiary institutions. Federal tertiary institutions are teaching hospitals that are owned by the federal government across our 6 geopolitical zones. So you can see a specific characteristics of interest that we have talked about here. Now, if you now want to do, for example, okay, I don't know if I should talk about, don't let me go, let me go out of that scope. Also, all registered voters in California and the United States, patients with diabetes who are aged between 40 to 60. So we can see how that how sampling also helps us when we have a population. Now we now have, and we have talked about research being a program of inquiry, a systematic or methodical program of inquiry. And now in our population, we're not going to pick our target population, those who have the same characteristics that interest us, for us to be able to get what do you call it, accurate results for our programs of inquiry. We have talked briefly about accessible population, which is a key concept in research methodology, especially in health, social sciences, and educational research. It refers to a portion of target population that is realistically, you know, in the reach, contact, or to be included in the study, given practical constraints such as location, time, resource, and eligibility criteria. It also helps to see how it fits into the broader population structure. The target population is the entire group of individuals or elements the researchers want to draw conclusion um, about. However, studying everyone in the group is often is most likely, we have talked about how that is very impossible, which is why we rely on the accessible population. The accessible population is therefore a smaller, more manageable subset of the target population that is available during a study period. The accessible population is defined by practical and operational factors. These include geographical boundaries, such as patient attending specific hospitals or student enrolled in certain schools. It may also be limited by time, for example, individual available within a particular semester or survey window. Administrative and institutional access also plays a role, since researchers may only be permitted to collect data from organizations that grants approval. We're also going to be talking about ethics in ethical considerations when we are deciding our uh, sampling technique and which sampling technique is suitable for what research design. Inclusion and exclusion criteria further narrows the accessible population by specifying characteristics participants must have and must not have. In research design, the accessible population is important because it is from this group that the sample is actually drawn. Why researchers aim to make inferences about the target population, the data collected directly represents only the accessible population. This is why the accessible population must be clearly described in a study, so readers can judge how well the findings might generalize beyond those who were studied. Let's talk about what are the several characteristics of an accessible population. It is identified, it is identifiable, it is identifiable, meaning members can clearly recognize and be defined. For example, when we talk about pregnant women, I mean, we can know that oh, this person is pregnant. And what also characterizes such person? The person must be a woman, right? It's definitely a woman by default. And the person is also pregnant. So it is identifiable. Many members can clearly recognize and define. It is reachable, implying that when we go to antenatal clinics, we can easily see them there. Influencer can contact and recruit them using available methods. It is limited in size compared to target population. Everybody cannot be pregnant at the same time, right? So per period, per time, and also depending on our interest, we can look at pregnant women within first trimester, second trimester, or third trimester. And it is shaped by real world constraints rather than purely theoretical considerations. For example, if the target population is all adults with hypertension in Nigeria, the accessible population might be adults with hypertension who attend some selected, and so many of you have seen research that say in selected hospitals in Oyo State, in selected hospital in Ekiti State, in selected hospital in Kano State, in selected hospital in Ebonyi State. So these are some of the reasons, the inferences, the theoretical considerations behind those topics, and when you read your journals, those topics and titles you see during the study period. Also, registered nurses working in inpatient medical and surgical wards at University College Hospital UCH, Southwest Nigeria, and University Teaching Hospital Enugu, Southeast Nigeria. Another example in education could involve a target population of all secondary school students, while the accessible population is students in government-owned schools within a particular local government. One major issue related to accessible population is representativeness. Because the accessible population may differ from the broader target population, there is a risk of selection bias. For instance, people who visit hospital may differ in important ways from those who do not. Researchers must acknowledge this limitation and, where possible, use appropriate sampling techniques to reduce bias. I hope we've been learning techniques for us to actually determine sampling when it comes to carrying out a research. What do we think about when you have a problem in mind? Who are those who are our what do you call it? Our interests. Who are our population of interest? How do we now cover those who will be able to help us to carry out our inquiry in a very, very, very methodical way? In research reporting, it is essential to describe the accessible population clearly. This includes stating where the population is drawn from, the time frame, and any criteria used to define eligibility. Please note this. Doing this improves transparency, aid the interpretation of the result, and allow other researchers to replicate and compare studies. Now let's talk about sampling frame as one of the learning outcome of this uh, discussion this class this afternoon. A sampling frame is the complete list or operational representation of all elements in the accessible population from which a sample is actually selected. It serves as the link between the accessible population and the sample, ensuring that unit eligibility for the study has a known chance of being selected. It also serves as a critical tool in ensuring that sample represents the population accurately, allowing researchers to make valid inferences based on their findings. Having a well-defined sampling frame helps to minimize bias and improve the reliability of results. As we have seen, we have talked about population, we have talked about sampling, we have talked about various processes. Now we are talking about sampling frame. It is a complete list of representation of all elements in the accessible population. Sometimes it's not all the samples that we have in our accessible population that are eligible for our study. For example, in qualitative study, there's something we call focus group discussion, which is also a method of collecting what do you call it? Collecting our data. Now, when you want to do a focus group discussion, it's very, very important that even when you have a sample, those who could participate are only those who have some characteristics in common. So I'm sure when you get to data collection, that would be more explained to us. But I believe that we're understanding the concept of sampling frame. Sampling frame is not the population itself, but it's a practical tool that identifies members of accessible population. It can take many forms depending on the study. Example include registered nurses in a hospital, a class list of students, an electoral roll, a household listing, or a database of employee in an organization. When what matters is that it accurately represents the accessible population. The quality of sampling frame is critical to validity of a study. An ideal sampling frame should be complete. That is, it includes all eligible units, accurate, and free from duplication so that no units appear more than once. When these conditions are not met, sampling errors such as coverage error may occur. What is coverage error? Coverage error happens when some members of the accessible population are omitted and when ineligible units are included. For example, if the accessible population is all registered nurses in a teaching hospital, the sampling frame might be the hospital current registered staff. If some nurses are missing from from the register or former staff are still listed, the sampling frame will not perfectly represent the accessible population, which can bias the sample. I hope we are getting some of these examples that we are giving. The verified and up-to-date staff duty roster or human resource database from the nursing department of University College Hospital Ibadan and UNTH Enugu, listing all nurses assigned to medical surgical ward. Note, the HR list is outdated, e.g., it could include transferred nurses or retired nurses. So it is an imperfect frame. So when we talk about sampling frame, we have talked about our accessible population now. So sampling frame is for us to now ensure that out of those who we are recording that, these are the accessible population, do they actually meet all the criteria that count them worthy to be counted as a sample in this program of inquiry, or to call them as our accessible population. We have given several examples to cover that. Still on sampling frame, inclusion criteria are specific characteristics or conditions that individual must meet to be part of a target population for a study. We have talked about this, and this is just to remind us all these things that we have talked about. Exclusion criteria are characteristics or conditions that disqualifies individuals from being included in the target population for a study. So exclusion criteria are characteristics and conditions that disqualifies individual from being included in the target population for a study. So let's talk about the 5 must know facts about sampling frame. A sampling frame should ideally include every individual or unit within the target population to ensure comprehensive representation. If the sampling frame is incomplete or outdated, it can lead to selection bias, which will affect the overall validity of the study's conclusion. In descriptive study designs, a well-constructed sampling frame enhances the ability to generalize findings to broader population. Researchers often use lists, registries, or databases as sources for constructing sampling frames to ensure they cover all necessary elements. The quality of sampling frame directly influences the reliability and the accuracy of data collection during descriptive studies. So now let's talk about sample. We've been hearing sample since. What is sample? Sample is a subset selected from the sampling frame. Sample is the subset selected from the sampling frame, which is intended to represent the population for the purpose of the study. A sample is a subset of the population that is actually selected and studied in a particular research project. It consists of individuals, objects, or units from whom data are collected and is and it serves as the basis for making inferences about larger populations, usually the target or accessible populations. Usually the target or accessible populations. We should not forget our population, target population, accessible population, sampling frame. Now that we are on sample, sampling is the process of selecting a subset of observation from an entire population of interest so that characteristics from subsets, which is also a sample, can be used to draw conclusion and make inferences about the entire population. Because studying an entire population is often impractical, researchers rely on sample to save time, cost, and effort. A well-chosen sample should be representative, meaning it reflects the key characteristics of the population from which it is drawn. When a sample is representative, conclusions drawn from it are more likely to be valid and generalizable. Sample can be selected using different sampling techniques. Probability sampling method, such as simple random, systematic sampling, stratified sampling, and cluster sampling, which gives units a known and non-zero chance of selection. And we also have non-probability sampling methods, such as convenience, purposive, quota. We are supposed to also have snowball, which do not provide equal or known chances for selection and are more prone to bias. The the size of a sample is donated by n, small letter n. We know we have capital letter N. Please note small letter n. Why there is no single formula that defines a sample. Statistical formula used to determine an appropriate sample size and to calculate sample statistics that estimate population parameters. Common sample statistics and formula include, we can say our sample mean, for instance, the population rule is estimated by what? By sample mean. And we can say our X bar. We can say our summation X over N here, where X representing individual observation and N is the sample size. We can say our sample variance here, which is S raised to S square equals summation X minus X bar square divided by N minus 1. You can also see the sample standard deviation, which is S square equals square root of our sample variance. And we also have our sample population. We can say our P bar over X over N, where X is the number of sampled units with a particular, where X is the number of sampled units with a particular characteristics. In probability sampling, the probability that a unit is selected from sampling frame is often expressed as probability of selection, which is N over N, where our N is our what? Our sample over our N, which is the what? Population, where N is size of population or sampling frame. Example, 300 nurses systematically selected from the combined staff list of 2 teaching hospitals. The relationship target versus accessible. So think of it as a funnel. You can start with a global group or narrow it down to a group you can actually visit or survey. Don't forget we have talked about our target population as all individuals who meet a study criteria globally, wherever you are from. Target population. Example, all pediatric nurses in the country working with oncology patients. As a population, the portion of that target population available to you to for recruitment. Example, all pediatrics oncology nurses working at LATEC Teaching Hospital during dry season in 2024. So why accessible matters in nursing? In clinical setting, accessibility isn't just about geography, it's about gatekeepers and logistics. So let's talk about some factors and their research context. Now, geographic factor. It is. Let's talk about some factors and their what do you call it? Their research context. We have geographic, we have temporal, institutional, and language. And geographic, we can see the research context here. Is the study limited to a single ward? We want to understand a whole hospital or a whole district. You can see selected hospital within your state, within Ibadan North local government, within southern Nigeria, within southwest Nigeria, within global south, within global north. So those are contexts. Those are factors and context. How context and factors come into play. We have the temporal. Are you sampling the daily shift? If so, your accessible population exclude night nurses. And that is why when you're writing your research topic or title, I'm sure you have been taught, yeah, what do you call it? What are the key elements that must reflect in your research topic? The five W's and one H: whom, where, when, where, and how. So that is where all these factors also have their what do you call it, their role. You also have the institutional. Do you have the ethical approval from the IRB access to for you to access patients in the ICU or only in the general ward? And language, does your accessible population include non-English speakers or only those who can read your consent form? The beauty of our research is that all these things we are saying, I beg you, don't think they are actually boring. No, I'm telling you, they are practical. I work within the policy space, and all these things are what we deal with every day to make decisions on policies that shapes our world. I've had privileges to work within the Commonwealth space, within the United Nations space, and these are things that we carry. These are the things that we do to design policies, to even design laws, legislations. We do a survey. We have our target population. We know our sample in that target population. We take questions from them for us to be able to take solid inferences to influence decision making on how a policy should be implemented or what law should go about or what not should not go about. So all of these things, I don't want you to see it as, oh, they are abstract, or, oh, is this, they are everything. Like everything we are talking about, you are going to need, you are going to use so everything you are going to practice, everything you will use. So let's move forward. Let's talk about the importance and purpose of sampling. Sampling plays a critical role in research and statistics because it provides a practical and scientifically sound way to study large populations. The importance and purpose of sampling goes beyond convenience. They directly affect the quality, validity, usefulness of our research findings. One important purpose of sampling is visibility. In many studies, the population of interest is too large, too scattered, or too difficult to study its entirety. So sampling makes research possible by allowing researchers to work with a manageable number of units while still gaining meaningful information about the population. Without sampling, many studies in health, education, economics, and social sciences would be unrealistic. Sampling is only important for saving time. Collecting data from every member of the population can take months and even years. And sometimes, let me tell you, this thing we are talking about, there's something we do within the policy space. We call it policy somersaults. When we are not able, when you see policy somersaults, trust me sincerely, there's a sampling error. When probably they are doing need assessment, when there is a sampling error, hmm, sometimes it leads to policy somersault. I'm just telling you about how very important sampling technique and our sampling is. in whatever program of inquiry that we are into. Don't forget when I talk about program of inquiry, I'm saying research. But because we have a broader what concepts to cover, that's why I'm talking about programs of inquiry, which is synonymously used, which I'm using simultaneously in place of research. So let's move forward. Importance of and purpose of sampling. By studying a carefully selected sample, researchers can obtain results in a shorter time frame, which is especially important in time-sensitive studies such as disease outbreak, policy evaluation, and program assessment. Also, we have cost reduction is another key reason, which is another key reason sampling is used. Large-scale data collection requires significant financial resources for personal, material, transportation, and data management. Sampling reduces this cost while still allowing reliable conclusion to be drawn, making research more economical and efficient. Still on the importance and purpose of sampling. Another important purpose of sampling is to manage variability within a population. Proper sampling techniques such as stratified sampling ensure that important subgroups are adequately represented. This helps capture population diversity, reduce bias, and leading to balanced and credible results. Now let's talk about ethical considerations in sampling. Ethical considerations further highlight the importance of sampling. In medical and social research, involving an entire population may expose many individuals to unnecessary risk or burden. Sampling limits participation to those necessary for achieving research objectives, thereby reducing potential harm and respecting participants' rights. Sampling also allows for repeated studies and comparison because sampling is efficient and cost-effective. Researchers can conduct surveys periodically to monitor trends over time, compare groups, and evaluate impact of interventions. This would be difficult or impossible if whole population had to be studied each time. The importance and purpose of sampling lie in making research visible, efficient, cost-effective, ethical, and scientifically valid by, by carefully selecting a representative sample. Researcher can generate accurate insights, draw reliable conclusions, and make informed decisions about the sample interests. So what are the advantages of sampling? It enables visibility. Studying the entire population of all hypertensive patients in West Africa is impossible. Sampling makes it real for us. We have talked about that. Improve data quality. It also, I don't want to, because of our time, I want to really, it enables visibility and improves data quality. I don't want to go too much into all the examples I've given. I have prepared a note, which I've also shared alongside the slide after the class. We still have a very long way to go. So characteristics of sampling. An effective sampling frame is essential for ensuring that samples selected in the study accurately represent the population of interest. In nursing and research, a good sampling frame improves the reliability, validity, and reliability of findings. So let's talk about some of the key characteristics of an effective sampling frame. It is complete. Completeness. The frame should include all eligible units of the accessible population, and no member of the population should be missing, and there should be no ineligible units included. That's the standard. Two, accuracy. Information in the frame should be up to date and correct, as errors in names, contact details, and utility status can lead to coverage error. Three, uniqueness. No duplicates. Each unit should appear only once in the frame, as duplicates can give some units a higher probability of selection and introducing bias, and that will introduce bias. Also, relevance. The frame should reflect population defined by the study objective, so that the participants chosen for the study are only those who meet the inclusion criteria. Then 5, accessibility. Units listed in the frame should be should be reachable for data collection, and there should be a practical way to contact or recruit participants. Stable over time. The frame should remain valid during the data collection period, as frequent changes in the population can affect representativeness. Sampling is crucial for protecting patients and maintaining ethical standards. So let's move forward to, because of our time, um, so let's talk about, okay, so let's move to, let me briefly talk about sampling in public and community health nursing. Sampling enables surveillance and planning. Health researchers use sample to estimate disease prevalence, assess health needs, and evaluate programs. These findings guide resource allocation, health education campaigns, and preventive strategies without requiring data from every individual in the community. The importance and purpose of sampling in nursing and health research lies in making studies ethical, efficient, accurate, and applicable to patient care. Through careful sampling, nurses and healthcare researchers generate evidence that improves clinical practice, protects patients, and strengthens health systems. Sampling formulas are usually used to determine sample size, selection probability, and allocation across groups. In nursing and health research, these formulas help to ensure studies are scientifically sound, ethically appropriate, and capable of producing reliable evidence for patients and public health decision making. So now we are moving to the formulas one after the other. This is Yamane formula for sample size determination. We call it, the name of the person that provided this formula is Taro Yamane. And I'm sure some of us are familiar with this formula. This formula is very popular within social nursing and health science because of its simplicity. So we can see that the formula is N, where our N is our sample size, yeah, equals to N the population size over 1 plus the population size here, and E is the level of precision and sampling error. Hopefully, I'll be able to talk briefly about precision or sampling error. So this is Yamane. So what are the indications? Where do we use Thyroid Yamane? That's part of the assignment I'm going to give to you, because it has to be a participatory class. So this is a sample size formula for estimating population. You can see it here as well, where we have our N. We know what our N is, sample size, which is equal to, what's our Z? Our Z square. Did we mention something about Z square in the previous? I think we did. Yes, I think we did. What's our Z square? Can somebody on mic or mute and tell me what our Z square is? We have Z square, and what do you call Z square? This is sigma, and we have our D. What's our D here? D is acceptable error. You're already seeing it on my screen. Our D sigma square is what? Remember our variance standard deviation that we have talked about?
You said D is margin of error.
Yeah.
And
We talked about our Z earlier. When we're calculating, when we're doing calculation of
critical. I think that was a critical value.
is it critical value? Are you sure it's critical value? Can you all remember what we did in our variance and our standard deviation? Because everything, I was telling you that we are going to refer back to all those things we have said earlier. Everything we have said, as the class moves on, we'll be referring back to everything. Well, anyways, part of the assignment I will be giving the class is you have to write. You write a one pager on what are the indications. What are the indications to using Taryamani formula to calculate sample size? What are the indications? So you can know that what are the indications for using Taryamani sample size formula in research? When do you use it? Is it for finite population? Is it for infinite population? When is the right time to use? What are the indications? Where is it applicable? Then what study design do you apply Taryamani, what do you call it, formula, some type formula to? So I am still listening. No. So what is our Z here? You can see this is acceptable error around the mean, right? And I have told us about the sigma. This sigma square, we know what our sigma is already. So what is Z here?
I think when you mentioned Z earlier on, I think you were mentioning some, like you said, a particular confidence level or so. That's why I was mentioning critical value. So I think that was when you mentioned some certain percentages.
Okay. So part of the assignment I'm going to give you all is because many of you don't know the formula, but you don't know what this, and that is why in the slide I ensure to interpret what each of the, what do you call it, or the figures in the formula, how we come about it, because it's very important. You know, when many people say they want to understand statistical data analysis and they see one tech person, I usually tell them you need to go to somebody who studies statistics. Those are people who can teach you research data analysis, not those one that one tech person is. No, you need to understand the fundament, and that's why I'm going through all this theoretical route so that we're able to really also help us. By the time we are building data analysis skills, we'll be able to understand the indications behind some of this. They don't just come from heaven. So for this Taryamani formula, I think I have even given some of the insight there. So for this sample size, for this, what do you call it? Sample size formula for mean estimation to calculate the population mean. Identify, spell out what each of these mean. Especially this Z. I have interpreted what the sigma is already. What is this Z? It's part of the assignment, and we'll talk about it in
You
the
said it's
classroom.
confidence interval, sir.
Confidence. So what brings about our confidence interval?
It's like a standardized percent already, like a percent that we're supposed to like use. We have to maybe check a table or something to go about it.
Okay. Okay, no wahala. You have an idea, but I'm not satisfied. Maybe in the classroom I'll take it further from there with your, so probability of selection in simple random sampling. What's our P? P is the probability that any unit is selected at B, which is equals to where our small n is sample and our n is what? Population or sampling frame size. Then systematic sampling interval formula is what? K equals n over n, where K is what? Sampling interval. You know what our capital N and our small n is already. Then stratified sampling allocation formula, which is proportional allocation, is commonly used in health research. We have our n, which is equals to what? You know, sometimes we have two capital N's, right? And I believe we know what those two capital N's stands for. Where n is what? Where n subset H is what? Is the sample size of the stratum of H, right? And
Yes, sir.
capital N is the sample size of the stratum of H, and N is the total size, total population size, and small n is the total sample size. Then for our, what do you call it? For our cluster sampling formula for number of clusters, we have number of clusters, which is n over m. What is our m? Where n is what? Is the desired sample size, and m is the average number of elements per cluster. So we also have something we call, this one has given us the draw already, Cochrane formula. I'm sure we also are very aware with our Cochrane formula. Where do we use Cochrane formula? When we have an infinite population. I be used when the population is larger than 10,000 or is even unknown. mostly infinite. All patients with hypertension in Nigeria, for example. So our N, we see N naught and our Z score, which is the standard confidence level, which the young lady said the other time. You also need to know the indication, how did we arrive at all of some of these things. It really helps us in our data analysis later. Sha. So we have our N naught, which is our Z score. What's our P, estimated proportion of population with characteristics, which is what, 0.5 if unknown, right? Remember our probability, which is 0.5 if unknown. And our Q is what? 1 minus P. Our E also is what? Margin of error, which is 0.05 for 5%. We also have now, I show it too. Part of the assignment, I was asking, what are the indications? We used Yamani's formula in finite population. This is the student-friendly formula. Everybody wants to use it. Use this when you have a specific known population. 450 nurses working in city hospital. This is the formula I was asking us earlier. Where N is required sample size, capital N is total sample size, E is margin of error expressed as decimal, 0.05. Randomization is used to select units. 3, it allows for calculation of sampling error and confidence intervals. Also, we have different types of probability sampling technique. We have the simple random sampling. In simple sampling, each of the units in the population has an equal chance of being selected. We got to call our random sampling technique. But when you have 100 people, everybody has a chance of being selected, even when you select them as random, and it will ensure accurate representativeness of the sample, draw an inference from the population of interest where we are making our inquiry, right? So each unit has an equal chance of being selected. Selection is usually done at random, using random numbers or lottery method. For example, when you do the lottery, you see that, for example, you have tally that is labeled 1 to 100, and you put them in a basket, right? Every tally in that basket has an equal chance of being selected without any form of bias. And that is one of the things that comes with probability sampling technique. And here we're talking about simple random sampling. Now here, the formula for selection here, as we see it, is what N. We know what our N is, the sample size over population size. That's how to do our random sampling method. Also, we have an example here. The researcher has a sampling frame of, we know what our sampling frame is, right? Of diabetic patients enrolled in a hospital diabetic education program. It's ID number 001 to 850. Using computer random number generator, they selected 170 unique numbers. The corresponding patients are invited to participate in a survey on dietary self-management. Every patient had a, a chance. And what is their chance? The 170 that was selected over the total number, which is what? 850. And that will give us what? 0.220% chance of being selected. So we also have systematic sampling. In systematic sampling, I hope you understand what simple random sampling is. Now, in systematic sampling, units are selected at regular intervals from ordered lists. The first unit is chosen randomly, then every kth unit is selected, and every kth unit is selected. So, for example, the formula for that is also our big N over N. So, the example here for us to be able to relate practically or pragmatically to what we are talking about is from a clinic appointment registered of 500 patients seen last month, right? We know our total number is 5. We need a sample of 50 for a phone satisfaction survey. So our systematic sampling will be what? N 500 over 50, which gives us 10. So randomly pick a number between 1 and 10. So e.g. 4. Start with the fourth patient on the list. then select every 10th patient after the fourth. So this is a systematic. This is I'm sure you can understand the system that is being used here. Here in a clinic where we have 500, a total amount of 500 patients, we need 50, we need to pick 50 patients, right? So we'll do our calculation, our systematic sampling calculation by dividing the total number of the population, our population of interest, which is our what, our target population, over the sample population that we need, which is 50. So we divided it, and that's 10. So from 10, we randomly pick between any number between 1 and 10. So whatever number you have picked between 1 and 10, right? You now pick every what, select every 10th patient after that particular number. So if you had picked 5, that means your every patient, every number of patients, the patients you pick after that time will be the 15th patient. Then in that order. So it has a sequential, irregular, and that's why I said that you need to accept that irregular. So that is a defined sequential order of selection. So stratified sampling technique. The population is divided into stratas, subgroups based on important characteristics: age, gender, disease severity. Samples are drawn from the stratum, usually proportionally to stratum size. We have discussed this also earlier. So the formula for this is what we have seen. The n of the total number of the stratum size over total number times our times the sample. And that is the formula we can see in front of us, which is also interpreted. An example is here. A study on nurse burnout stratifies the target population, which is what? Hospital nurses. For example, we have nurses burnout. So we are looking at those who are working within the clinic, within an hospital. By what type? ICU, general medicine, surgery. The first burnout level are theorized to differ, and that's the truth. If 40% of the nurses in ICU and ER have high stress, and 60% in general ward have sample of 200, oh sorry, and 60% in general ward, the sample of 200 will be drawn to reflect this. 80 from ICU and ER list, and 120 from the general ward list. Since our total N is what? Is 200. Selected randomly within each stratum. So each of the nurses will now be selected within that stratum. And what is stratum? Those who work in ER, that is the stratum. They are all nurses, right? But the stratums are by their area of specialization. So we can stratify. That's how we stratify by a unique characteristics. So anytime you have to stratify or you have to do this type of what you call a sampling technique, you stratify by very unique characteristics. In this case, the example they are giving in an hospital, we're not just saying all nurses here now. We are stratifying nurses who work in ER, nurses who work in pediatrics, nurses who work in medical ward, so that capsules and samples can be randomly selected from that sample. I'm going to send us a note that also gives us what we call it a more clear, other clearer examples that will make it more pragmatic to us. Then let's talk about cluster sampling. The population is divided into clusters, e.g., hospitals, schools, communities. A random sample of clusters is selected, and then all or a sample of units within those clusters are studied. So do you understand? The population is divided into clusters, hospitals, for example, schools or communities. In fact, clusters also could be socioeconomic factors. Although that and sometimes people mistake cluster sampling to with
Stratified.
stratified. Yes, people really mix a lot of things within. People really mix it up a whole lot. And the distinctions is always very there. Now let's look at the formula. The formula for cluster is what? N, where our name is our desired sample, and M is what? The average number of units per clusters. So clusters, how do we exactly know what a cluster is? So for example, you can see here we are talking about an hospital. Whereas it's stratified. We're not just talking about nurses in the hospital. We are interested. We are going lower, right? To okay, what are the stratum that makes up an hospital? What are the units? So you can see that, for example, hospital is even a more larger sample than the units that are in the hospital. I hope we can differentiate between cluster and stratified now. It goes now into into a more smaller, what do you call it? More smaller units. So cluster sampling, we have a multi-stage and it has different stages. I'll explain what multi-stage is for. Multi-stage, most time when we want to do a national survey, maybe you want to carry out a study and you are using Nigeria. You know, we have talked about that. So Nigeria is a very large, we have a population that we don't even know. We've been only living on statistical predictions since the last census. Now you want to carry out a study that is focused in and on Nigeria. Now, how do you get your sample? And that's such that there will be equal representativeness. In this example, we have a national survey on childhood immunization coverage in Nigeria. Cluster one, what are we going to do? We are going to randomly select 20 local government areas from all the 774 local governments that we have in Nigeria. We are selecting as random, right? That's the plan. The thing is, within each, before we even randomly select at, what do you call it? Before we randomly select, you know, at what do you call it? At I think I was trying to adjust this part. Before we randomly select all local governments, we have 774 local governments across Nigeria. So we are randomly selecting based on senatorial districts. You know what makes a senatorial district? Multiple local governments, right? What makes a local government? Multiple. What makes a local government? Multiple wards. And what makes, after we have the senatorial district, we have the federal constituency, right? Senatorial. So we have Nigeria, we have the senatorial district, we have, no, let's say we have Nigeria, we have states, we have senatorial districts, we have federal constituencies, we have state constituencies, we have local governments, and we have wards. So that is how you will now do your staging. So in this case, at Nigerian level, we can say we want to go straight to maybe senatorial district. And we know that when we're talking about senatorial district, we have talked about state already, right? So we can randomly say that, oh, in Nigeria, we have 6 geopolitical zones, right? So within the 6 geopolitical zones, we are now randomly selecting states. Sorry, this slide is I wanted to correct it. I remember I was trying to correct it, but I didn't know how I omitted it. So we won't just go straight to local governments since it's a national study, right? We go to the geopolitical zones. And what are the geopolitical zones we have in Nigeria? We have the southwest, right? The south, right? The southeast. Then we have the north, the north central. We have the northeast. We have the northwest, and we have I think we have just 3 north: north central, northeast, and northwest. North central, northeast, northwest. Yes. So from all those geopolitical zones, we will now. So how many local governments make a geopolitical zone? So in southwest we have 6 local governments. Sorry, we have 6 states in southwest. So within southwest, we randomly now pick a couple of states. Maybe we are picking like 2 states. And if we are picking 2 states in southwest, that means randomly we are picking 2 states across other geopolitical zones. So when we now pick 2 states, the next thing we are going to do, because this is different stages. Are you following the stages I'm telling you now?
Yes, sir.
Yes, sir.
Thank you. So when you have chosen states, we have stratified Nigeria into the geopolitical zones. That's our stage 1, Abby. Stage 2, we are randomly selecting states. So we are picking 2 states from each of the what of the geopolitical zones. So from the states, we will now also randomly pick. So each state has 3 senatorial districts, right? So let's say we are picking. Here we arrive at 20 local governments. Yes, there are central districts that have at least a central district that have at least 18 to 14 local governments. So let's pick a senatorial district. Within a senatorial district, you can now say we are picking 20 local governments. So can you see the stages? We are what? We are also stratifying, but at a larger scale, right? So let's say at what do you call it? At state level, we have fixed our what do you call it? Our senatorial district, and we have fixed local government, which is representing each senatorial district. So within the selected, what do you call it, local government, we are going to now select randomly again communities. Communities. Remember we said words, Abi, but in the context of this study, which we are using as our example, we are picking randomly 10 communities. Within each of the communities, we are also now picking households. Can you see how we are coming from national, from something that is at national level? We are stratifying we are stratifying them into clusters, into clusters, into clusters, into clusters, and we are coming down, 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 down. We have picked local governments. From local government, we are choosing households. And from household, we can now choose children. And not just children, we are looking at children of under 5. So at that place, we'll now be applying our inclusion and exclusion criteria. Do you get it? So multi-stage can be a very big tree, But one thing about multi-stage is it ensures absolute representativeness. It's very, very practical. I've done a lot of studies that have been multi-stage, and I really, really enjoyed the process. So let's talk about some of the importance of probability sampling technique in nursing and health research. It ensures representativeness of sample. I mean, we also can see that has been demonstrated. It also reduces bias in selecting patients and participants. It allows for statistical analysis to estimate population parameters and calculate confidence intervals. It enables valid generalization of findings to similar populations. Probability sampling provides a scientific and structured way to select a study participant, which is critical in nursing and health research, where accuracy, representativeness, and ethical considerations are paramount. So this is an image that is showing us uh, how that probability gives us very high representativeness. Small sample size, low representativeness, sample not fully reflective of population, and large sample size. And you see where you can apply large sample size. This is just demonstrating for us how that cluster sampling is very, 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 very good, and it helps us to manage a very large, sample size. It gives us high representativeness and also reflects the population's reality. So let's talk about, and most times when you are using non-probabilistic, you also apply them to mostly, I just don't want to generalize as quantitative studies, but yes, you use them mostly in quantitative studies. Now let's talk about non-probabilistic sampling. Non-probabilistic sampling is a sampling method in which the selection of units from the population does not involve randomization, and not every unit has a known or equal chance of being included in the study. It is commonly used in nursing, health, and social research when probability sampling is impractical due to time, cost, and accessibility constraints. The key features of non-probabilistic sampling are: selection is based on researcher's judgment and convenience. The probability of selection is unknown. Findings may be less generalizable to entire population because of potential bias. So what are the common types of non-probabilistic sampling techniques? We call it purposive. Purposive is, oh, I have an information that it's just like I said that I'm going to a maternity center. By default, I know that people who go to maternity center are first a particular gender, people who are pregnant, Abby, and they are usually women, right? So I can say, oh, purposefully, I am going to this place. Not to carry out another study. I say you are going to University of Badon. You know that students are going to be there. So you are particularly going to a particular population, a particular population of, what do you call it? A particular population of interest. So you are doing it purposively. So purposive sampling, also called judgmental sampling, involves selecting participants based on specific characteristics or knowledge relevant to research question. The researcher uses their knowledge to choose persons who are most likely to provide the information needed. What are the key features? Selection is intentional and not random. It is used when researcher wants to study a specific subgroup or expert participants. Often used in qualitative studies, case studies, or when studying rare conditions. An example is in nursing and health. Studying ICU nurses' experiences with patient safety. The researchers select only nurses with at least 5 years of ICU experience. And you know that when you are collecting data from, what do you call it? There are ways, there are method of data collection, right? So research is a very methodical, is very, very interesting. You just need to understand all the due processes and you will enjoy it to the fullest. Research on patients with a rare autoimmune disease. The researcher recruits only those patients who have a confirmed diagnosis and are under treatment at specific clinic. A qualitative phenomenological study aiming to understand the lived experiences of head nurses managing the first wave of COVID-19. The researchers deliberately select 15 head nurses who worked in a designated COVID-19 treatment center were in the role for at least 6 months during 2020 and are willing to share deep experiences. So all of these things, some of the methods of data collection in quantitative, I'm sure you have heard that KII, key informant interview, right? And the other time I was talking about FGD. FGD has a bit of inclusion and exclusion criteria that you can consider. But KII, you already know your inclusion and exclusion criteria by default. You know, oh, there are particular features, there are particular criteria that makes this particular sample a worthy participant in this research. What are the advantages? It ensures that participants have relevant knowledge of characteristics useful when studying rare condition or specialized population. The disadvantage is subjective, relies on researcher's judgment. Results may not be generalizable because the sample may not represent the entire population. Participants are selected based on specific characteristics or expertise relevant to the study. For example, select something with at least 5 years of ICU experience for a study on critical care practice. We have the quota sampling as well. We have talked about the convenience, right? So now let's talk about quota. Quota sampling is a non-parametric sampling method where researchers divide the population into subgroups, strata, and then select a quota, a specific number, quota participants from the group to ensure representation, often based on characteristics like age, gender, income, making it faster and cheaper than random sampling, but potentially biased as selection within group isn't random. It guarantees subgroup inclusion, but findings aren't fully generalizable because it lacks randomization. So, for example, you say you are coming to Ibadan to come and study, or probably you are looking at people with low income household. I mean, when you talk about Ibadan as your first set, for example, not everybody has a low income household. So you are probably basing it on based on socioeconomic characteristics of socioeconomic features. So you already know what you are looking for. People who are not probably any more than this. So people who are probably doing petty jobs who are doing this, who are doing that, and all of that. So that is what this quota sampling is all about. There's a particular period that also makes not to randomize. The researcher ensures that certain characteristics are restricted in the sample to a specified proportion, but selection within the group is not random. Advantage ensures of good representation. Disadvantage selection bias still possible because randomization is not used. And it's just like how you cannot just categorically do some research. For example, we want to talk about vaccination factors that well, we are looking at knowledge, attitude, and knowledge and attitude of a particular population towards vaccine hesitancy and vaccine confidence. And you want to see the role that socioeconomic factor or education, for example, you want to use education as your stratum, as your as a what do you call it? Your stratifying metric. Or is it because they are educated that they are taking vaccine? Is it because they are not educated? Is it because they live in rural community? Is it because they don't? Is it access? Is it because they have access? Is it because they don't have access? That is where this quota are somewhat what do you call it? Somewhat the formula for quota allocation is functional quota allocation is equals to number of what? The number of size for subgroup, which is equal to the total population size of the subgroup and total number of the population size, the total sample, then you times it with total sample size. So this is an example I have given here. I'm going to send you the notes and also a slide. This is also another example I try to give here. We have a lot to cover, so I will move faster today. Consecutive sampling. Consecutive sampling involves recruiting all assessing participants who meet inclusion criteria over a specific period of time until desired sample size is reached. It is often used in hospitals or clinics where patients arrive sequentially. So what are the key features of this sampling? Simple and practical, with selection bias compared to convenience sampling, but still non-random. Suitable for clinical or hospital-based studies. You can see that there's something unique here. Who meets inclusion criteria over a specific period time until desired sample size is reached. For example, a note such as studying blood pressure control might recruit every academic student using a clinic over a period of time until reaching the required sample size. A study on postoperative infection rates could include all surgical period between the last 6 months. Also, a clinical study on postoperative pain management outcomes for knee replacement patients. A researcher enrolled eligible patients admitted for the procedure at a specific hospital over a period of 6 months. This minimizes selection bias within the setting and provides a good overview for patients. So, snowball sampling. Snowball sampling is a method where existing participants recruit or refer other patients who meet the criteria. This technique is particularly used for outreach or hidden population where complete list of population is unavailable. For example, let's talk about female genital mutilation. For example, it takes probably somebody who is probably attending uh, clinic care for therapy for whatever to also know for who had FGM. Probably a research wants to do about their coping mechanism, what their experiences have been like, sexual experience has been like, or childbirth or something. It could also be other serious, what do you call it, serious cases, maybe robbery, people who have robbery experiences. But female genital mutilation is a very critical and a very good. So it is somebody who probably also knows somebody who, because they had conversation about it, or they are in the same, what do you call it, or they are possibly in the same um the same care group or the same, what do you call it, therapy group. What are the key features? Recruitment spreads like snowball, starting from a few known participants, right? Often used in qualitative research or study involving a rare condition. I did this snowball sampling just was it last month or this month? I had a work I'm currently consulting with UNFPA on, and we are working with survivors of female genital mutilation. And of course, how do I know who had female genital mutilation done? Is it showing on the face? I don't know. So it is somebody that we have identified or that self-reported the person is the one who brought another person. That other person brought another person. That other person also knows somebody that brought somebody else. That somebody also knows somebody in one church that brought somebody else. Somebody also knows somebody, and that is what snowballing is all about. Because they are hard to reach. You might not even be able to say this is this and this is that. So it is mostly self-reported or through referral system. So often used in qualitative studies as said, right. Probability of selection is unknown, so results may not be fully generalizable. Existing participants refer or recruit other participants, often used for hard to reach populations such as patients with rare disease or marginalized group. What are the advantages? Effective for population that are difficult to identify. Disadvantage can lead to oversaturation of certain networks, reducing diversity. For example, somebody talks, okay, here we are even giving an example of people living with HIV. It's possible that you cannot even know who has HIV and who does not have HIV. Probably somebody who has been attending the clinic is the person that can now refer, oh, I know this person, I know that person, and all of that. So you have convenience sampling as well. Convenience sampling is simply involves selecting it simply involves selecting participants who are easily accessible and willing to participate. This is most straightforward and commonly used non-probability method, especially in clinic and hospital settings. Participants are selected because they are easily accessible. For example, a hospital may recruit patients who are currently in the clinic. Importance in nursing and health research. Useful when population are hard to reach or list of all units are unavailable. It also saves time and resources when probability sampling is impractical. It also allows researchers to focus on specific patient groups or healthcare workers relevant to the study, often used in pilot study, qualitative, and exploratory studies. The limitations, because the probability of selection is unknown, non-probabilistic sampling carries a higher risk of bias and limits the ability to generalize findings to broader populations. In summary, non-probabilistic sampling is a practical and flexible approach in nursing and health research when access, cost, or time constraints make probability sampling difficult. But researchers must acknowledge its limitations regarding repetitiveness and like general the generalizability. So selecting an appropriate sampling method and sample size. All you have to do first define your research purpose. Currently, I have a small grant and I'm trying out a study in Borno State on. I'm trying to find out on the impact of climate change and I'm trying to find out the dual burden of impact of climate change and conflict, how it has how it has affected access to care for people living with soil emitters. Recall that Borno State is in northeastern Nigeria. It is conflict afflicted, and they have very serious experience with extreme heat and other climate conditions there. Right now, I am doing a qualitative study where I am also where my sampling approach is also purposive. I know people, specific people. I am going to go and meet. and there are characteristics to all of it. So these are some of the things that have been included in the notes. It is very self-explanatory, and I really employ it because I took a lot of time to actually write that note. So apart from this slide, I'm going to send the note to you. I really implore you to read the note. So define the research purpose. It's very important that you have a purpose why you want to do a research, right? When you define your research purpose, do you want to do a descriptive research? Maybe you want to check prevalence of hypertension in adults, or maybe you want to do an analytical or comparative research. Maybe you want to compare BB control in two groups. These are often called randomized control trials. Or you want to do an exploratory or a qualitative research where you want to explore experiences, give the experiences of ICU nurses. So like I said, most time when you are doing a qualitative study, non-probabilistic sampling, they help you to explore lived experiences, and there are quite a lot of types. There are a number of types, up to 10 types of qualitative studies you can use, and different sampling techniques that also work based on your study population interest. Also, when you are doing a descriptive, descriptive study, probabilistic sampling technique are your go-to. And I have given you easy formula to calculate and to conduct your study in the image you are seeing on your screen. Let's now talk about comparison of sampling technique in quantitative and qualitative studies. Let's compare. The main purpose of sampling in quantitative studies is to obtain samples that is representative of population and allow statistical generalization. The main purpose of sampling in studies is also to obtain participants who can provide rich, in-depth information about a phenomenon. Don't forget, in qualitative studies, we talk about method of what do you call it? Of getting data. You have the idea, that's in-depth interview. You have your what do you call it? KII, that's key informant interview. You also have your FGD, which is focus group discussion. So let's talk about research focus. In quantitative study, right? What are you doing exactly? You are measuring, you are testing hypotheses. There's prevalence, and you are testing for relationships. And these are some of the things that will inform how you are doing your analysis. And let me call your attention to this. When you are writing your research objective for a quantitative study and a qualitative study, there are key features that you must pay attention to. There are key features. I think I wrote it in somewhere in the notes. There are key features to pay attention to. Just give me 1 minute. I want to quickly check our notes. There are key features to hold on. I want you to also write this because it's not in this slide, but I know I mentioned it in the notes. So there are some common verbs. There are verbs that flies that you can easily use. Now, when you are doing a quantitative study, you can see when you're writing objective, you can see to determine, to examine, to compare, to identify, to investigate. Those are some of the what do you call it? Those are some of the um, um, verbs: to determine, to measure, to assess, to examine, to compare, to test, to estimate, to evaluate, to quantify, to analyze. So those are some of the key, what do you call it, verbs that you use in a quantitative research objective. But when you're writing a quantitative research objective, you use verbs like to explore. When you say exploring, understanding, describing, to explain, to interpret, to examine, to elicit, to identify, to gain insight into. By default, that is a qualitative object. That's the qualitative study. So when you want to find an objective for a quantitative and a quantitative study, your tenses, the tenses you use, it matters. It matters. It matters. Um, it matters a lot. It matters a lot. And that is why here you can see that comparison of, when as you are doing the comparison of sampling within quantity and quality, you can see the chart focus is to measure, to test, to test, to check for prevalence, to test relationship. Where for qualitative, you are seeing to explore, to understand meanings, to understand experiences, to process. So what are the sampling approach? For quantitative, they are mostly probability sampling. For qualitative, they are mostly non-probability sampling. What are the common sampling methods that you use in a quantitative study? Simple, random, systematic, stratified, cluster. What are the sampling that you use in a quantitative? Purposive, convenience, snowball, theoretical, and theoretical sampling. Then let's talk about the role of randomness. Random selection is essential to reduce bias. The only reason why we do random selection is to reduce bias. And that is for quantitative, but in qualitative, randomness is not required. Relevance and experience matters. And you can see why you have to appreciate the knowledge of sampling technique in the research. Then let's talk about sample size determination. For quantitative, yeah, determine you are determined to using statistical formulas based on confidence level, margin of error, and power. I wish I have time to also explain what margin of error and power means and confidence level in what you call it, but we don't have the time. So part of the assignment is I want you to read up on margin of confidence and power in sample size determination. So for quantitative, these are very important things you need to look at to determine using. You have to use statistical formulas based on confidence level, margin of error, and power. Also, then in quantitative, you determine by data saturation when no new things emerge. You do sometimes in quantitative, you do thematic analysis, content analysis. There are so many analyses you do in qualitative research. The sample size is usually large in quantity, and in quali, it is usually small to moderate. The use of formulas, yes, in quantity you use formula, sample size formula as central, but in quali, no statistical formula. It is guided by depth and saturation. Then let's talk about representativeness. It's very important. Samples should mirror the population. In quali, it's not the primary goal. Depth and variation are prioritized. Generalizability is very high in quantity. In quantitative studies, finding can be generalized to the population. In in quali, limited statistical generalization findings may be transferable. Flexibility of sampling. Fixed, it has to be fixed before data collection begins. For quality, it is flexible and may evolve during study. How do you handle attrition? This is accounted for by inflating sample size by statistical judgments. There's a formula for that. And there's a way to calculate your attrition rates so that you don't have issues when you are analyzing your data. Then for quality, less emphasis is on that. Continued improvement until there is saturation. So example in health, survey on prevalence of hypertension among adults, and in quantity, we do interviews to explore patient experiences with chronic illnesses. So let's talk about quantity. So quantitative study emphasizes repetitiveness, randomness, statistical power, while qualitative study prioritizes information of richness, relevance, depth of understanding with sampling guide by data saturation rather than formulas. So let's talk about sampling in quantity and quantity. We have talked about depth, we have talked about all of this. We have talked about this. So let's talk about sampling process. Sampling process is a systematic sequence of steps that researchers follow to select a subset of participants from a population in order to conduct a study. In nursing and health research, following these steps carefully ensures the sample is representative, reduce bias, and strengthen the validity of finding. The step includes that you have to define the target population, clearly identify the entire group about which you want to make an inquiry or conclusion. Include characteristic relevance to the research questions such as age, disease status, or professional role. Example, all diabetic patients attending clinic in the city or all ICU nurses in the hospital. So sampling process is simply a systematic sequence of steps that shall follow to select subset of participants from the population in order to carry out a study. So what do you do in this during sampling process? Specify accessible population, determine the subset of the target population that can be realistically reached for data collection, consider constraint like location, time, medical approval, external access. Select your sampling frame. We are talking about sampling frame. Choose a a sampling method as well. Determine your sample size, and you implement the sampling procedure. Recruit participants and collect your data. Review and adjust if necessary. Then this is a summary of the steps again for what do you call it, for sampling process. So let's talk about sampling error. Sampling error is the difference between characteristics of sample and the true characteristics of population. You will all remember definition and concept where we talk about we have defined sample and we have defined population. So sampling error is the difference between the characteristics of our sample and the true characteristics of the population. It occurs, it occurs because a sample is the only subset of the population, and by chance, it may not perfectly reflect the population. It is unavoidable in sampling, but can be minimized. The larger and more representative the sample, the smaller the sampling error. Sampling error is different from bias. Bias arises from systematic errors in selection or measurement, while sampling error is random. For instance, a researcher wants to know the average blood pressure of diabetic in the city. If only 50 patients are randomly selected, the sample mean may be slightly higher and lower than the true population mean due to chance. I mean, you can see that in this example that we have cited. That difference is the sampling error. I mean, you cannot want to judge the average blood pressure of diabetic in a city, and you are choosing only 50. Does that represent the entire what do you call the population in the city? No. So that is what sampling error is talking about. So how do you reduce sampling error? You increase sample size, use appropriate probability sampling methods, ensure the sample reflects the population characteristics. And this is the mathematical formula to calculate our sampling error. You can see S bar minus mu. You know our mu, yeah? Then for population proportion and sample proportion. So sampling error is equal to sample proportion minus population proportion. These are the formulas. Then you have the standard error, which is used to estimate the variability of the sample in statistics. I can see our sigma. You can see the what do you call the standard error equals to sigma, which is population standard deviation over square root of n, which is our sample size. And for proportion, you can see it is equal to square root of population proportion into bracket 1 minus population proportion over n, which is our sample size. Okay, let's talk about the key relationships. Key relationships, larger sample size is n, smaller standard error, it means more representativeness. When you have a larger sample size, you have a smaller standard error and you have more representative sample. But when you have a smaller sample size, you have a larger standard error and a higher sampling error and less representativeness. So we give an example here. I'm going to share the slide. We'll have to read up on that because we have a bit of other things to talk about. So let's talk about representativeness. A sample is representative when it accurately reflects the characteristics of the population from which it is drawn. I'll come again. A sample is representative when it accurately reflects the characteristics of the population from which it is drawn. So representativeness ensures that the results of the study can be generalized to the target population. And what is the importance of representativeness in research? Generalizability. Findings can be applied to wider population. Validity reduces systemic differences between sample and population and improving internal and external validity as well. Evidence-based practice. In nursing and health research, representative sample ensures that interventions, policies, guidelines derived from studies are applicable to the real population. Report that I talk about policy somersaults. When there is no representativeness, when there is poor sampling, that is when we have some of our policies although there might be other errors like lack of funding, adequate training for those who will implement them, and all of that. But most times when you have a policy that's somersaulted, we call it policy, when a policy does not work. Example of policy that did not work in Nigeria, Buhari new currency. So now it has not worked because you know, need assessment was not, carried out. So what are factors that affect representativeness? Sampling method. We have talked about that. The probability sampling increases why non-probability sampling may reduce it. Sample size. We know that larger sample size tends to help us to be more representative. Diversity of population. Stratification and quota sampling ensures skills subgroups are also included. Studying patient assessment in hospital, if sample includes only young patients, it may not represent older patients' view, including all age groups, which proportionally improves representativeness. Then what is the relation between sampling error and representativeness? High representativeness equals to low sampling error. Low representativeness equals to high sampling error. So I made a table for it to also explain that. I give examples of that here. Um, Practical. Sorry, hold on. So I want to give us some practical guidance here. They are just examples on how we can go about some of these things. Start with infinite population formula to calculate your N naught. Check if population is finite. If N is smaller to moderate, apply finite population corrections. These are just practical guidance I put in the slides. It's also in the note that I'm going to send. Adjust for expected non-response. Also, this can also be optional. Divide them by a certain number of response. And I gave an example here. You have to determine the sample size correctly because it's essential in nursing and health researches because it ensures that your study has sufficient power to detect meaningful effect while minimizing cost and effort. The formula differs depending on whether the population is finite, known, and limited, or infinite, very large and effectively unlimited. All of these are already been discussed and they are also in our notes. Yeah, so I think this is the final part of our class. Yes. How do you report sampling in a methodology session? It's very, very many people don't know how to report sampling in a methodology section of, and your research is all about, if there is no methodology, you're not doing research. Your research is all about the methodology. And when anybody is speaking methodology, they are first checking your sampling techniques. In nursing and health research, the methodology section must be must clearly describe how participants were selected for transparency and reproducibility. It must describe the population, the target population, the assessment population, your inclusion and exclusion criteria. You must specify the sampling method. What method did you use? Is it probabilistic or non-probabilistic? What type of probabilistic? What type of non-probabilistic? You can see all the examples that we're giving here. You can also describe how you recruit them. I think I'll also share a couple of method sessions to see how samplings are recruited. In fact, I'll give it. I'll make sure I will include in the notes different reports, how to report sampling method. I'll go and add that to the note, and it'll be more robust. Then you describe how you recruit your, what do you call it, the recruitment process. Then you address representativeness and bias. It's very, very important. You must address representativeness and bias. And you must also report a participation flow. So those who you invited, those who are eligible, is there going to be a consent and all this ethical process? Also, your sampling must also reflect the ethics, even if it's a line, talk about the ethic process, what you are not fronting, what you are making sure to implement in the process. It is very, 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 very important. So thank you so much. This will be the end of our class. So